Okay, guys, I'm gonna start sharing my screen. Let me know when you see it. Right, hold on a minute. I need to allow. Okay, guys, I think I'm gonna have to rejoin. Okay, this is because of the Mac permissions to share my screen. I will rejoin in a minute, okay? Just stay online, do nothing.
Yeah. No.
Okay, guys, I think you should be able to see my screen now. Just one of
Your
you
screen is
can.
visible, but
Okay,
showing
all
but
right.
not in the full screen.
What do you mean not in the full screen? You can change your view in the WebEx application.
Yeah, I can see it's full. We can continue.
Right.
Yeah.
All right, guys, a bit about myself and the course. Right, my name is Sukesh. I am a CCIE security, and here we're gonna do all the major firewalls like Checkpoint, Palo Alto, and also F5. Like with respect to F5, it's not the firewall part that we cover the LTM part, right? That's kind of more in demand versus the firewall because this is where F5 starts, the basics of the device and the firewall and the WAF and all the other features they build upon LTM, right? So this is kind of the basic of the device. Okay, so here I understand all of you all are here for checkpoint. Okay, a moment, somebody cannot hear anything. Give me a moment.
Yeah, we are for checkpoint.
Sorry, come again?
Yes, we are here for checkpoint only.
Right, yeah. I know. What's wrong with Khalid? No, how do you do that? Okay. How do I tell you that?
Good evening, Showcase sir.
Hello, good evening.
Yeah, myself Gopi. Before you going to the topic, can you explain about stateful and stateless firewall? Because checkpoint is a stateful firewall, right? So
Right.
what is the difference? Then
That's exactly where we will start. Don't worry. We
sure,
will
sir.
start at the very basic. Yeah, don't worry.
Thank you.
All right, I think we'll let him figure out how to join audio. That's a pretty basic thing. Let's start. So, when we talk about firewall, be it any firewall, guys, right? Let me just tell you a few generic concepts about firewall. What firewalls do in the network, why are they important, and how do they affect your network? Affect as in affect for good or change your network. So how that works is, for example, let's say any network will have these three portions, right? And in between these three will be your firewall setting. This could be a checkpoint, this could be a Palo Alto, this could be any other vendor, right? The naming convention, the terminology could be different, which I'm about to use, but it's more or less the same thing. So what is this? The inside network, that's what checkpoint calls it. Palo Alto would call it the trust zone. Cisco would call it inside. Checkpoint calls it inside. Palo Alto or Juniper or FortiGate, they call it trust. But these are just names. So all you have to understand, this is your internal network that we are referring to. The network which is under your administration. I, as a network administrator, if I look at this picture, so this is the domain that I control, and this is the services, which is DMZ. Let's say, let's take example of very small thing that you use in daily basis. Let's say you all connected via WebEx, right? Let's take example of WebEx. So when you connect to WebEx, Cisco is a huge network, right? So you are not connecting to Cisco or to their internal network. If we take this mini diagram as the Cisco network, somewhere here is all of the Cisco network where the employees are working, and it's internal to them, right? What we as customers, when we connect to the DMZ servers. DMZ stands for demilitarized zone, if you don't know the full form. And what it stands for is, it's more like if I have to tell you in the layman's term, it's more like a living room, right? Or like the drawing room where you know sit the guest. If any guest comes at your place, you make them comfortable in the living room or the hall or drawing room, whatever you call it. You don't take them straight away to the kitchen or bedroom or to the washroom. Those are like your more private areas, I would say, right? If you were to map network with house. So this is like the living room of the network. Okay, the customers or the guest, they come in, take the services, go back, right? They have no business coming in to the inside network via DMZ or directly to the inside. No, never, right? Which means customers coming from outside or internet or a zone which is not administered by you, it could be another company, internet, or any other network, right? So you would not want them to access the internal network. Never. You would never want to allow this, right? If you have any services that you want to host, you want to allow, for example, any web service or any email service or any kind of HTTP service that you wish to offer for the customers, that will be kept here in the DMZ. Now, there could be more portions to it, like internal DMZ and external DMZ. Now, what is the difference? Internal DMZ could be, where, let's say you are running some development or a non-prod environment, wherein the users on the inside, they want to access the services, right? Before you host the services in external DMZ, you may want to build them, test them, and play around with them, right? So all that is happening in internal DMZ. These are standard terms in your network. You may not see these terms, okay? So it is all right. They may or the network designer or the architect, whoever implemented it, they may have used different terms as per their convenience or as per the instructions, right? But I'm telling you by the book. So understand from the access, implement this knowledge in your network. If you see in your network there are servers in a particular VLAN, and a particular access has been granted to those servers, and only certain users could access from outside or from inside, so you are referring to DMZ. They may have given a name differently, for example, services or servers, or by the name of the application that you have in the DMZ. But the point is, it is kept separate. The internal network is kept separate, and the services that are hosted are kept separate, right? And they are separated by two different interfaces of the firewall. All right, any question in it? This is what a firewall would do to your network. It will divide it into three different parts: inside, outside, and DMZ, or trust, untrust, and DMZ. Okay. Now, when you have to allow access, what kind of access would you allow by default or in general, right? You would want your inside users to be able to go out on internet. You would want that, right? You would want to allow that. Also, you would want to allow access to this internal DMZ here. This little bigger. Oh, it's here, sorry. So you may want to allow this access, you may want to allow this access, but at the same time, you would never allow this, right? From DMZ back towards inside. No, there will not be a good use case which will demand this kind of an access. No, it will never happen, right? And it can be more of a security breach if you're allowing this kind of an access, right? Where during the security audit and all, the auditors, they may point this as a correction in your network or correction in your security policies if you have this allowed. right? You would never want to have this, because what can happen is you are allowing this as well, right? You are allowing your outside users to come to the DMZ, and if at all this user here is an attacker, right? They may want to, gain access to the main area, right? To the main services or to the main network, right? So somehow if you have this allowed, this attacker here can come to the DMZ, because your firewall will have policies. Anybody from DMZ, because anybody from outside will be allowed to DMZ, because you're running a public service, right? A publicly available service, I mean. So the attacker here could try to, enter the inside network if you have this access allowed. So you would never want to have this. And also, you would never want to have this allowed, right? From outside to inside. Never. Now you may ask me that we are allowing inside to outside, but we are not allowing outside to inside. So how is the return traffic gonna come? Right? A valid question? Yes or no? Yeah. So answer to that is
Hello.
yes.
Can you repeat again question? Because actually outside to inside, you're saying that you're not requesting pass out now.
Right. What I'm saying is, since we understand that we're never going to allow inside to outside. Sorry, we are allowing inside to outside, but we are never allowing outside to inside. So how
But
is
sir,
the return traffic gonna come? A question arises, right?
yeah, but sir, actually कभी कभी प्रोडक्शन के लिए आउटसाइड से भी इनसाइड ट्रैफिक आता है ना.
That inside again, the name could be inside, right? Here,
Yes.
if I'm referring to internal DMZ, I can refer this as inside, right? In my internal meetings, or casually, like you just said, that traffic comes. It does, but
Yeah.
it has to be separated from the actual inside network. You're getting my point? These are just names. They can be anything, right? You will understand when we try to configure the firewall, right? You will get to know. But what I'm saying is, let's just say that it is 10 network here, right? And this is pretty much anything. So we are allowing from 10 to anything, but we are not allowing from anything to 10, right? I just made it more specific. So how is this gonna work if we are not allowing this return traffic, right? So that is what I'm coming to next. What happens is, answer to that question is the stateful packet inspection. The word stateful, what does that mean? It means you remember about a certain packet. Okay. Let's take example of a router, right? You have incoming traffic, routing table, right? And routing table entries. The packet comes in with the destination IP address. The router will look at the destination IP, check the matching route into the routing table, forward it to the exit, and then forget about it, right? This is stateless behavior. You don't remember what you did, right? The router here is not maintaining any kind of table to remember what all connections are going through it, right? There's no remembering happening. Same goes with the switch. Switch would look at the MAC address, look at the CAN table or MAC table, and then do the forwarding, then forget about the packet. Firewalls, on the other hand, they remember, right? How do they remember? With the state table, right? Or the session table or connection table, different names, right? State table or session table or connection table. Connection table. How does that happen? You have the connection going through the firewall now. Right? Let's say you go to Gmail. You are allowing this communication. The return packet comes in. Now, what is my security policy? My security policy is allowing from inside to outside. Guys, I request all of you to be on mute, please. Right? Go on unmute when you have a question. Let me mute everyone. Okay, everybody's on mute now. So in order to make this happen, we only need one policy. That is, we are allowing from inside to outside. How does that work is, it works with respect to the request. Okay. Since the request was generated from inside, right? It meets or satisfies this security policy that is allowing the traffic from inside to outside. The packet will match this policy. The firewall will decide that, okay, this packet is allowed to go out, right? And it remembers that, okay? It remembers that this packet 10.0.0.1 went out to this destination called 𝐍𝐞𝐭𝐰𝐨.com. Then this reply packet here comes back. Now this reply is coming back from Gmail, and the firewall remembers that yes, we did have a packet which requested something from 𝐍𝐞𝐭𝐰𝐴.com, and hence Gmail is replying back, right? It is not requesting, it is not sending a SYN packet to initiate connection. It is just replying back, right? So this reply packet will be allowed without having to go through the security policy check, right? This reply packet will not have to require a security policy to allow this. Why? Because the firewall remembers. The firewall remembers that there was a packet that went out, so there will definitely be a reply. A reply is expected for a request, right? There's nothing wrong with that. But what if from outside the same Gmail or the same IP address send a request? Now the request here could be a send request, right? So this request will have to go through the security policies. The firewall will simply check, am I supposed to allow this traffic, right? So if there is a policy that allows this communication, which is outside to inside, right? Let's just write it like this. Outside to inside. This is the list of security policies that we are building. So if you have this, then only the security policy will be allowing this request. So what do we learn? Because of the stateful behavior of the firewall, because the firewall is remembering the request packets, because the firewall is maintaining a state table or a session table or a connection table, we do not have to create security policies in order to allow the reply packets to come in. We only need the security policies for the request packets, right? And the direction, okay? I'm talking about the direction of the flow here. The flow of the traffic is how? It is from inside to outside because 10.001 initiated the communication. So how is the flow? From inside to outside. So always, whenever you have to allow certain traffic, always allow it with respect to how the request is going to flow. If the request is flowing from outside towards DMZ, right? Something like this. So what will you allow? In the security policy, you'll allow from outside to DMZ. You will not allow DMZ to outside or outside to inside. No. Always create your policies specific. Be as specific as possible while creating security policies. All right. So all of this behavior is stateful packet inspection. Now, what if an interviewer asks, what is stateful packet inspection, right? How will you explain? You don't have to draw the diagram and explain everything, right? All you have to say is when the firewall remembers the packet, the request packet, the reply packet does not have to go through the security policy, right? That is stateful behavior. That's it. And all the security policies that you create, they are stateful in nature. Again, I said the same thing in different words. The policies that you create, they are stateful. That means if you have the security policy allowing this communication outside to inside, or let's take this example here, inside to outside, right? Then your replies from outside towards inside will automatically be allowed. You don't have to create this policy outside to inside. Okay. Any questions around this? Anybody? No questions? That's strange. Did I explain it too well?
Sir,
I-
can you repeat once more for stateful in any another example?
Hang on, I see some questions here. Can demilitarized zone is a physical or logical subnetwork that contains and exposes an organization's external facing services. Yes, Khalid, that's absolutely correct. Okay, another example is simple. Take any example from client to server perspective. Okay, that could be something like this: the firewall, DMC, the client here sending connection, right, from outside. So what will be the security policy to allow this communication? What will be the direction in which you allow the traffic outside to DMZ? Of course, the replies will go back, but the replies will go back using the same policy. For the replies, you don't have to create DMZ to out. No, you don't have to create this in order to, make this flow works. You don't require this. Why? Because this policy here is a stateful policy, because it is being created on a stateful firewall, right? The architecture or the way it has been coded, developed by the developers, right? It is stateful in nature. All right, I hope that explains.
Okay, got it. Thanks, sir.
Now this was all generic. This is true for any firewall in the market today.
I have one question. Like in many of the firewalls, some like client asked to open the bidirectional rule. So in that case, we apply the policies on both the interface from the incoming as well as outgoing, where the traffic is flowing. So in this case, like we are saying that if we have to allow the bidirectional rule here, so it will work on the stateful table accordingly. We don't need to apply policy on the other end.
Excuse me. Sorry. See, bidirectional, the word bidirectional means, okay, let me tell you. Let's say this is the flow. You send the request, you get the reply, right? For this, you need a policy which allows traffic like this. So what do you say? Is this a bidirectional traffic or a unidirectional traffic?
Just a unidirectional traffic. We are just sending the traffic from inside to outside.
Right, but most people here get confused that since we are having traffic in both sides, why not we call it bidirectional? The word bidirectional means the direction of sending the request, right? When you have to allow bidirectional, that means both ways you are allowing the request to flow, right? Let's say this is request 1 coming from inside to outside. This is request 2, which is coming from out to in. So this request will go through this policy, right? Out to in, right? Now let's
Yes.
talk about the response. So this is the response 1. No, this is response 2 and this is response 1, right? Request 1, response 1. So this response 1 will not enter your traffic, will not enter your network through this policy, which is out to in. No, it will always use the connection table or the stateful remembering or the stateful behavior of the firewall. This response will never go through the security check. Same goes for this response.
Okay, so basically we don't
All
want
I'm
to
saying
allow the
is,
policies from outside to inside.
right, you, and if you have to allow the traffic bidirectional, always keep in mind for the request, right? When you're creating the security policy, always keep in mind the client server model, right? The three-way handshake.
Okay.
Always remember this. Always remember who is sending the SYN. That means the request.
Okay, so for an example, when we are creating the policies from inside to outside, and they are, suppose an example, there are 4 ports we are allowing. Okay, but in the response, we want additional some of the port that we have not created in the policies. So what will happen in that case?
No, that will never be the case. I tell you
Okay.
that will never be the case. If you're sending the traffic on a certain port, let's say you're sending the SYN on port number 8088. So the replies will come from this only, right?
No, actually, I face an issue like in AWS. I think we are allowing the traffic for the AWS voice traffic, and the voice seeing the traffic flow is quite different. Like when we are sending the traffic, we are sending that on the some port TCP some port. I'm exactly not remember the port number, and while we are receiving from back from the AWS, then the port number is different. So I allowed the policy on different ports. That's why I'm asking this question.
See, the a particular application again, it could behave a little different. You are sending the traffic on 8088 and the response is coming back from 8089. Is that what you're saying?
Yeah, yeah, correct.
See, that is again a very customized and a very particular use case for a particular application, right? In such cases, you will have to be as specific as possible, again, as I mentioned. So you will have to create this, you will have to allow this traffic, right? And because this is a custom behavior, right? Because this is a custom behavior, you can register this application. Okay, listen to me very carefully. You can register this application behavior with the vendor, right? Who is the vendor here? Either Checkpoint or Palo Alto or whoever. They all have their database which knows about all the applications available to us. Right now, if you are using this custom application and it is a very popular, well-known application, right? You would want this to be registered with them, and you would want to, create application signatures. And in that case, you will not have to allow this explicitly. The firewall will be, understanding the application that it is going to 8088. It is expecting it back from 8089, right?
Okay.
The similar things happen with FTP,
Yeah,
right?
20 and
Active
21.
and passive FTP. Since because the firewall understands FTP as an application, you don't really have to allow those explicit connections coming from different ports, right? It
Okay, like
works
when we
with just one application, with just one security policy.
got it, while from the firewall will according to the application it will work. Whatever the
Right.
port they use, they automatically use that port and allow the traffic.
Yeah.
Okay, thank you.
Sir, I have a question. For bidirectional, we have to use the port specific. Then that will be fine.
Sorry, come again.
Sir, I want to say for bidirectional scenarios, we have to give the port specific.
For bidirectional, you have to be for always you have to be port specific and as specific as possible.
Okay. Okay.
Right? Later we will understand that allowing a port, just the port, is not sufficient. Right? There are more ways that we can identify the application.
Filtering the port, about 65K ports are available.
Right.
Okay.
But when you allow 80, right, you're
Mhm.
allowing HTTP, right?
Yes, this is the so
But
simple
what
and
under
everyone can access
HTTP,
it.
right? HTTP can carry multiple applications, and what sort of application is this? Is this
Yes.
Facebook, Gmail? What kind of traffic is this, right? So the
All.
firewalls nowadays, they can look up to the packet in layer 7 as well. They can look at the payload and decide if this is to be allowed or no.
Okay. Got it, sir.
Right? So not just on the basis of port number, always keep this in mind.
Three-way handshaking.
Right. So whoever is sending the SYN will
Okay.
dictate the direction of the traffic
Okay.
and also the direction of the security policies that you create.
Okay, sir.
Sorry guys, I'm a little unwell. Okay. Now this was all generic. All of the firewalls in the market, they behave the same way. And all of the firewalls are next generation firewalls. They whichever whatever is available today, right? What does next generation firewall mean? The legacy firewalls, for example, Cisco ASA, right? It does not have the capability to look at the packet beyond layer 4, which means all of the allowing, all of the parameters of the packet that you can define in a security policy, they are up to layer 4, which means you can go as specific as you can define source IP, a particular source IP, single IP. You can define single destination IP. You can define single port number. That's the maximum that you could go in the legacy firewalls. Guys, hold on. I'll be right back. Okay, give me a minute. Okay, I'm back. The next generation adds on to it. You can define the user who is sending the traffic. You could define the application, right? You could define the content of the packet, right? If it is a file, an exe file, a zip file, gaming file, right? You can define URLs that it is going to with URL filtering, right? So this is all layer 7 stuff. For example, all of this is happening on port 80, right? HTTP. You could be playing games on port 80, right? Since it is web. You could be using Gmail, you could be using other web services. There is no way to differentiate that, right? For the legacy firewall. But here, you have more parameters to narrow down to a particular type of packet, right? And as I mentioned, more specific, better it is. So here you were only using 3 parameters, but now you are using these many parameters, right? So there is no such question that how many parameters the firewall would use. It's just an example that I gave you. Next generation firewalls, they have all other ways to identify a particular packet, right? And checkpoint also is a next generation firewall. All right, so moving towards checkpoint specific things. The operating system very first. They call it the Gaia operating system. They did major changes after the version R77.30. Okay. They did major changes in the GUI, major changes in the way firewall handled the configuration management, more so related to configuration management, right? The packet flow, the way it handled the security perspective of the firewall, it remained more or less same. Only the way you configure the firewall changes a little. The checkpoint firewall has, 3 main components. Now, listen to all of this very carefully, right? You have 3 main components. You have the first thing you have smart console. The second thing is the smart manager. And the third portion is gateway. This is your actual firewall. In all of the checkpoint documents, they call it smart secure gateway, right? Or just secure gateway at times, or just gateway at times, right? So the gateway term here is not referring to the routing gateway or the default gateway that you're used to, right? Gateway here means the firewall, which is actually allowing your traffic, which is actually handling your traffic. The manager here does exactly the same thing as your manager, right? He tells you what to do, but he won't do things, right? So he will tell the firewall what packets should be allowed and what policies, any kind of configuration change, configuration management, new configuration, all of that needs to be done via the manager. Okay, now how do you access the manager? You access the manager in 2 ways. Using the smart console. What is a smart console? It's an application, right? It's a Windows-based application. Now, you have a question that should we Can we not have this on a Linux system? Answer is no. Of course, you can run virtual machine, run Windows inside it, and inside that Windows VM, you can run Smart Console, right? But technically, you are running it on Windows again, right? So the most stable way and the only way Checkpoint supports it is when you run it on Windows. The other way is you access the manager through HTTP. The HTTP way of accessing is only related to a particular device. You can access the firewall as well, which means, let me just separate them. So what is this? This is a Windows PC which has installed Smart Console. This is, it could be a hardware or it could be a VM. Mostly it's a VM, okay? Even in production, the manager, because it is not handling the traffic. The gateway in all of the legacy data centers or networks, I would say. Why legacy now? Because it's all cloudy now, right? Everybody is moving towards cloud, and in the cloud, it's all VMs, and you know you get hybrid or just cloud, depends on the requirements, right? So this again could be a hardware or it could be a VM. The legacy networks, the legacy data centers, always hardware. On the cloud, it will be a VM, right? Integrated with the cloud solution, whatever you're using, AWS, Azure, or Google, or Oracle, or whatever you're using. Now, this guy here, the administrator, is gonna use the smart console or this PC here to access both the devices. One way is through the smart console, that is the application. The second way is the HTTP. So I was talking about HTTP that got us here. So when you use HTTP, you can access the device. It could be the gateway, it could be the manager. But when you access it with HTTP, you can only configure the device um, with respect to the device specific settings, which means if you access the gateway, you cannot create security policies, right? You cannot create VPN, you cannot create URL filtering, you cannot create NAT, or you cannot configure the firewall in that terms that it can be used, right? You can only configure the firewall with respect to the management related things, right? For example, the device name, DNS, right? Routing, all the routing protocols, anything that static or dynamic. If you have to make any routing changes to the firewall, you have to access it through the HTTP or the web browser way, right? Then again, what do you call it? NTP. These are all device specific settings, right? Same goes with the manager. You can change device specific settings with HTTP access. When you access it through Smart Console, okay, the Smart Console will only talk to the manager. The Smart Console will not talk to the firewall directly, right? It's more like the customer, if you talk about the operations. So the customer only gives the requirement to the manager gets it done by the gateway, right? Think of it that way. So you as an administrator, when you use Smart Console, you access the manager will access the gateway, and that is how you will push the configuration on the gateway. You will make all the changes here, all the config is here. You will do all the changes. Let's say all the production traffic is running back and forth through this firewall, and you are making changes here, right? Make mistakes, do blunders, everything remains with the manager, right? The gateway is not affected at all. Unless you push those wrong changes to the firewall, which means you install the policies or you install the configuration onto the gateway. All right, all the components, is it clear? Checkpoint likes to refer all of this as the three-tier architecture, right? Or three-layer architecture. What are those three layers? Console, manager, and the gateway. Now, the good part is it could be implemented in different ways, right? Smart console will always be separate, right? You cannot club it with anything. But the second and the third device, which is the manager and the gateway, they could be on the same device, right? So what is this operating system here? The Gaia operating system, it is sitting on a Linux machine, right? The checkpoint firewall, it is nothing but a Linux machine hardened and configured as a firewall, right? So when you access the firewall first time or access the Gaia OS first time, that's when you tell it that are you going to behave as a manager or you are going to behave as a firewall or you are going to behave as both. Yes, which means on a single device, hardware or VM, you can have both manager and gateway on the single device, right? You call it standalone architecture. This is not a three-tier architecture now, right? It's a standalone architecture. I mean, all the components are there, but you call it standalone since the manager and gateway is on the same device. Second, doesn't look like a PC. These icons that I'm drawing, you understand what it is, right? This is the PC that I'm drawing. Instead of, going the hard way, I just like to do it this way. Anyway, so that's your smart console, manager, and gateway. Again, could be hardware, could be VM for both manager and gateway. This is your three-tier architecture. Different. They are not standalone devices. This is being managed by a dedicated manager. And yes, you could have multiple gateways, all being managed by the same manager. Right? So you access the manager, do the configuration changes, and push to a particular firewall or to intended firewall wherever you are making changes. Third way is third way is when you have hybrid model, right? Hybrid means you have this device which is acting as the manager and gateway both, right? And it is also managing other gateways, right? Kind of combination of both. This is the hybrid model. All right, any questions on this?
I have one question. In standalone model, how many gateways we have to created only one or much more than that?
Standalone is just one device, right? And when you
One man.
add more gateways under it, it becomes hybrid.
Okay. But our device is one, hardware is one only, right?
Right, one, yes.
Okay, got it.
All right, now let's jump in. Let's look at the device. Let's look at Smart Console for real and see what it looks like. Give me a moment. Let me look for the lab link. So that is rack is 9086. Right, let's add a new folder. Yeah, I want this to be on top. If you guys are using this, please let me have this name. Yeah, do not try and add AAA to your folder. Okay. So here I will add a lab. All right, cool. Simply double click this. Okay, so this is Checkpoint Security Gateway. The version is R81. What is the latest that they are running? I think it's R81 only. Checkpoint. I think, yeah, it is R81. We want two-guy operating system, right? One will be the manager, one will be the gateway. You see, I'm using the same boxes, so it is not different. It's just what we use it as. And of course, these are VMs, not hardware. Right? We will also need a Windows machine. Multiple Ethernet on this because we might want to go to internet as well. Right? I like the smaller icons. Now let's set up the network so that I can connect to both through the single interface. I will put in a switch here. This is like an unmanaged switch. You cannot access it. No VLANs, nothing, just like a hub, but not a hub. It's an unmanaged switch. By default, you're saying Ethernet 0 is the management interface on these checkpoint devices. So that is why I connected with Ethernet 0, because that's the default. Right, and another network that will help me connect to the internet. Just in case if we have to download smart console from internet, for that. Or for any other settings. Also, at later stage, we will go to internet via the checkpoint firewall. So let's give it internet. Okay. And this PC here will double up as the inside PC and also the management PC, right? Let's get started. While the devices are booting up, let me just give some annotations to them. 10.0.0 network. Actually, let's keep it standard. Right, that's our network. And sorry. This is .1 and this is not .1, this is .50, let's say, right? And the PC will be .10. Cool. Do I get rid of these WebEx controls? Guys, if you have question, try asking directly, right? Avoid chat. Not that I see questions in chat, just informing you guys. I always inform my students in the first class. I am not a multitasker, so I won't be very attentive with the chat. Anyway, you simply click on it and this should take you to the console of the Windows. Yes. Let's bring it out. Now, if you see in the network sharing center, we have two network, local area connection and two. So how do you know that which interface is which? So the numbers outside on the diagram here, you will see as Ethernet 0, 1, 2, 3, 4 in the increasing order. So just replace Ethernet with local area connection and in the increasing order. So local area connection here is Ethernet 0 and local area connection 2 is Ethernet 1. Okay. So the 0 network gets 192.168.1.10. So we have to configure it accordingly. 192.168.1.10. And I'm not giving a gateway right now because on the other network interface, we have the gateway with DHCP. Let me just double check. We do have the connection, but still. Right, so that's what we got from the DHCP. Cool. Then access the manager. By default, since we use the same device, remember we just said I need 2 checkpoint devices on that GUI template. So the IP address on them initially will be same. We will have to change that. Right, you see, this is what I was talking about. In order to configure your system, please access the web UI and finish the first time wizard. Which means right now, this is just the Linux operating system that you're looking at, right? It is not the full-blown Gaia operating system working as a manager or as a gateway. Right now, it is asking for commands, right? That what am I? Am I a manager or am I a gateway? Please configure me via the first time wizard, right? So for that, let's first check the interfaces. Show interface /ETH0 will tell us the IP address on it, and looks like this is the IP address, right? So I will change it on the manager. Where are we? We are on the manager, right? Now set, I always get confused with these commands between Palo Alto and this. They're more or less same. Yeah, set interface ETH0 IPv4 92.168.1.50. I think you can write like this in checkpoint, yes. Right? If you write subnet mask, you write a 255.255.0, mask length 24. This works, right? And you might want to, shut your interface and no shut your interface, right? So command for that is set interface ETH0 on or off, right? That's the command. Okay, and the command comes with tab, not question mark. Sorry. This is what you have to define. State on or off. So ours is already on, but just for the sake of it, I'll save it. Anything that you do via HTTP, we are not using HTTP right now. This is console. And anything that you do via HTTP gets saved automatically, right? There's no save button on the GUI. Gets saved automatically, right? But here you have to type in save config in order to save the changes in case you are making them via CLI. And by the way, there are very limited changes that you can do via CLI. So you'll come here to the CLI only for running the packet capture, making the route changes, and looking for the HA status or looking for the connection table. That's it, right? not much of things that you can do on the CLI. All right, so we changed it to 1.50. Yes, we did. So I will access with HTTPS first. And also 192.168 1.1. Right? Do you guys know why do we get these errors? Your connection is not private. Do you understand what does that mean, guys?
No, kindly explain.
No, I will not. This is not the right time. We have a dedicated topic for this, so that's when I will come back to this and explain. Okay.
Okay.
And I think the default password for these VMs is admin and admin123. The username is admin, the password is admin123. And this is the first time wizard that I was talking about. So what am I accessing? I am accessing 1.50. What do we want this? We want this to be a manager. Let's go next. What is it asking? It is asking for deployment options. You could use multiple ways to install this 𝐍𝐤 operating system. We are installing the system right now. The management interface you could change here, and later on also you can change. You can change it to be DHCP manually, whatever you want to, right? So right now it's configured. We will leave it as it is. And configure the interface to connect to internet. The manager is not connecting to internet, so I will leave it as it is, and I will leave the interface off. So that's the best thing to do always. Whenever you're not using interfaces, keep them down. Host name. I will give the name as manager just to keep it simple. In production, you can give whatever the naming convention you are following. Give domain names, give DNS servers in production, use proxy if you are using. In the lab, we're not using it, so I will do next. And the time, set time manually, that is the default. Also in the production, if you're using NTP, you could select this and put in the NTP information. Right. At this stage, you decide that you want this to be, okay, I haven't discussed this term yet. We will talk about it. This is multi-domain server. We have talked about the security manager or the management, right? This manager is going to manage the gateways, right? The multi-domain server manage the managers. Okay, it's more like manager ka manager, right? So in productions, how do you work is with the multi-domain server. Okay, but here the difference is very little. How it works, how the multi-domain server is set up, I will tell you. But for now, throughout the course, we will stick to the manager and the gateway. Towards the end is when I will talk about MDS or the multi-domain server. All right. The GUI and all, it's the same. You will not feel the difference because there is no difference. It's just that how you navigate to your desired manager through MDS. That is what you have to learn. So we will come to it towards the end when you know things about Checkpoint and you'll be comfortable working through the GUI. That's when I will introduce you with this. Right now, if I tell you, it will be too much for you to digest. So at this stage, we are selecting that either it will be a gateway or it will be a manager. And I clicked on next, and here you can decide. So I'm going to uncheck the security gateway. I will uncheck this now. And I will leave security management selected. This will be the primary manager, right? And that's it. And is this unit a part of cluster? Cluster means if you have devices in HA, if you have two devices, two managers, this is when you select it. Otherwise, you just do next. Use Gaia administrator admin, which is our current administrator, right? You can keep that, or you can define a new administrator. Simple things. I do next. GUI client that can log into this particular manager. Here is any IP address, but in network, in production networks, you would want to select it network, and only the management network should be able to access your security manager. Okay. And that's it. You have chosen your selections. You click on finish and it will keep installing. This will start the configuration process. Are you sure you want to continue? Definitely. So this will install things, right? Although you see security gateway here in the list, but it is not going to install security gateway, right? It is going to be the manager. Let's do the same thing to 1.1. And I'll run through these settings again real quick. They're all the same settings. Just the name. I will change gateway and do next for NTP installation. This time I will uncheck security management. And you see now the further options changed. Now it is asking for some dynamically assigned IP. Do we have the IP address assigned via DHCP? No. What is this? Secure communication to management server. Right? Take a minute and I will let you guys read through it. Can you guys read it or it is too small for you?
It's too small for us.
Too small? All right, let me see if I can copy this. Sorry, I am using Mac, so enough now? Awesome. Go through this. I'll be right back. Okay, guys, I'm back. I'm sure you guys are done reading it. Did you guys understand it? Guys, no, maybe.
We use authentication for we have to use a smart console and smart provisioning, right?
Right. So not just any gateway will be able to register with your manager, right? Or your
Yes.
manager won't be able to register with just any other gateway, vice versa. So this activation key here, it sounds like you need something from checkpoint, but no, this is just a one-time password, right? It could be any password, anything that you wish. Enter it. Just remember it because you will need it when you are configuring this firewall with the manager. And we'll talk more about it, how this is happening, what is SIC or SIC, right? How does that work? We will talk about it.